Okay, so there we are. So here I have a cloudlet. It's just a standard cloudlet. Now you've obviously been around everything, right? If I'm to record, I should probably do it a little bit more formal. So I'm sorry if I show you some stuff that you already know. But basically here is the entirety of the dashboard, every single component we have, and then you have the getting started thing here. Yes, Hyperlambda. So the easiest way to start out is the evaluator. And actually, if you have a cloudlet somewhere, most maybe you should follow me like hands-on, if you can. And then you can just like reproduce whatever I am showing you. So the evaluator has a lot of these guys, right? You click the load button and there's an example showing a lot of different types of snippets. Before we dive into them, let me just illustrate the structure of Hyperlambda. Hyperlambda, you can comment like this, or you can comment like this for the record. The structure is really simple. It's a graph object. It's a tree structure. And it's a tree structure to type out its code in pseudo C#. It's got string name, and it's got object value. And then it's got lists, node, children. That's literally the pseudo code for Hyperlambda. So everything you write in Hyperlambda basically transforms down to this, right? Basically a graph object like HTML or XML or whatever. So let me show you the syntax. Node 1, value 1. So here I have a single node. Whenever I'm creating Hyperlambda, I get an explicit outer node. It's not like XML where you have a document node. Hyperlambda gives you the document node for free, and it's like invisible. It's outside of here actually, right? And you can't even see it. This means that I can add node 2, value 2 here too. I still have a graph object with one root node, but the root node is invisible. If I want to add a child to this node, tab, child 1, child value 1, like this. And the tab, of course, becomes 3 spaces. So 3 spaces opens up a child collection, child 2, child value 2. And of course, children can have child, child 1, blah, 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 etc. So basically everything is a tree structure or graph object that happens to be Turing complete, almost by accident. Now, Hyperlambda, of course, as you know, Mosen doesn't have variables, right? And if I just try to execute, even though this is perfectly valid Hyperlambda, I can't execute it. Why? Because there's no slot existing for node 1. That is because by default, the Hyperlambda interpreter or evaluator will by default try to execute every single children node of the node you supply to it, assuming that every single children node's name is referencing a slot. And there is no slot in my application having the name of node 1. So if I want to have just a variable that is ignored by the Hyperlambda evaluator, I have to prefix the node's value, the node's name with a dot like this. So if I prefix this one with a dot and I try to execute it again, you see I get a new error. Node 2 does not exist. If I prefix this one with a dot, then it perfectly executes. So of course, this particular Hyperlambda doesn't do anything because it basically just declares 2 variables, if you wish, right? That's kind of like what it does. But now I can actually start adding existing slots to it. If I now do sets dash value colon x colon minus dot colon foo and I execute it, it actually does something. Now we changed the value of node 2 here from its original value being value 2 to its new value being the static value of foo. Why the static value? Because this dot here is actually a node too, right? And it's a child of the set value node. So the set value node takes one child, 1, 2, 3, and then it can take either a recursively invoked slot invocation or a static value or whatever, or an expression for that matter. So if I now go down here and I exchange this to get value colon x colon at dot node 1 and I execute it, see node 1 has value 1 here. And now node 2's value after execution is no longer foo, but it's actually value 1 because it fetches the value, get value, fetches the value of this expression. This expression leads to this node, then get value extracts its value, and then it sets the value of the older sibling in this particular level to the value of this. So this begs the question, what is an expression? You can hear me, Mohsen, right?
Yes, yes, I have a question.
Yeah.
We have a graph, we have a tree object, and we can make hierarchy structure. If for each node we have a slot, this value pass to that slot for do like a function, like a library. So if I have a slot named node 1 without dot, node 1, the slot run, the slot run my pass this value to that slot and run our
let me show it to you. Actually, I understand your question, and let me show it to you by actually creating a slot named node 1. So here I'm just starting out with the version slot, node 1 slot, node 1. Then let me just delete some comments here, make it slightly more easily readable. So here is the smallest possible amount of C# code that you can create to actually create a valid slot. If I now, of course, now I'm in localhost on my local code-based backend. So this is why I can do this. But if I now recompile my backend, I will actually have the node 1 slot. And let me show it to you. Let's just keep this guy open and open another window, at which point you will see if I now hold down function and control and space on a Mac or control space on Windows, if I type node, whoops, I need to refresh, I think. Node, why didn't it, because I'm on my cloudlets.
Yeah, it's
Thank you. Let me go to my local host machine. I didn't understand why it didn't show me the node 1.
Okay, I understand. Okay.
Yeah. So I have now, using C#, I have dynamically created a new Hyperlambda slot. And actually, if we invoke this now, and I restart here, and I start it with my debugger attached, and I set a breakpoint here, at line 10, we can actually see what is happening. Now, if I just if I now just invoke this code as is function F5, then you will see the node input here. Oh, come on. You will see its name here being node 1. Yeah. So this becomes the identity node of the slot invocation. You see, I didn't provide a value, so the value is null, and I didn't have any children, so the children are 0, right? However, if I continue now, I'll just let it continue, and then I add colon, how the world, and I invoke it again. then you will see node input here now. All of a sudden it has a value. How they work. Yeah, it still has no children, right? But if I continue and I do child 1, foo1, child 2, foo2, and I invoke it again, now you will see the input node. If I expand its children collection, there are 2 nodes. One of them has a name of child 1 and a value of foo1. The other one has a name of name of child 2 and a value of foo2. So you see how the C# graph object hierarchy basically ends up matching the hyperlambda structure here. And of course, if I now hold down shift and I click tab, I go 1 back. Basically, it deletes 3 spaces. If I now do howdy, you will still see that the input node has only 2 children. Why? Because this thing here, even though it's below node 1, it is not a child of node 1. Only these 2 nodes are a child of node 1. So I'm de-indenting myself back here, right? And of course, inside of the C# code here, I can do whatever I want to. If I kill my debugger and I add some code, input, because the nodes structure is a 2-way process. It allows me to pass stuff in and it allows me to return stuff out. This is why I'm reluctant towards referring to these guys as functions, because they're not really function, because a function has a signature, it has a return value, it has, I mean, a function is a fairly strictly defined thing, right? Now, this isn't strict at all. It just takes graph stuff and returns graph stuff. Hello there, my friend. Your name is plus input dot value, semicolon, save, terminal, recompile, rerun. And just delete this guy and ta-da. Hello there, my friend. Your name is Thomas Hansen.
I want to organize in my mind. We can divide to 2 parts. First part, it's about some syntax like how the things you explain, or loops, if some this thing syntax type, and I can find my way for syntax. I can find my way. The second part, it's about the slide you made before for a special purpose. If it's possible, please show me again the place I can see all slots, ready to use slots, and how I can do with that slot. For example, I know I can invoke API, call API. I can do something for CRUD operation in SQL. For thread you mentioned before, I want to know about the slide you made, and I can use that as a developer.
Yeah. So if I go back to my cloudlet here that I've got
Yes.
in our hub onboarding system, then as everything else, the answer to your question is a slot.
Yes,
the answer to everything in Hyperlambda is a slot. So when the question is, what slots does Hyperlambda support? Well, that's a slot vocabulary. And when you see I type the Y here, it becomes orange. Why? Because it's a keyword or a slot. If I execute this, I get a list of every single slot I have inside of Magic. And there's like, 292 of them. right? Now, I want to emphasize Hyperlambda is the by far easiest programming language on the planet to learn, because its syntax is so simple, right? It's just 3 spaces and a colon and optionally a type in between its name and its value, and then there are expressions. So all in all, I could teach the Hyperlambda syntax to the average, you know, mid-level junior developer within a couple of hours. But obviously the slots themselves are, you know, they take specific inputs, they return specific outputs, etc. So if I now, for instance, want to look for a slot and filter IO dot, now it will only, are you there?
Yeah, I listen.
Yeah. If I want to list all slots starting out with IO dot, then I can provide a filter condition to vocabulary here. And now you see I get zip stream, file copy, delete, execute, exist, list, load, save, move, etc. Unzip, copy, folder. If I want to see only the ones that are related to folder dots, okay. Now I only see folder slots. Right. So if I want to move a folder now, I can do io.folder. Let me create a folder first. Let me go into HyperID, and then let me general active folder, new folder, test1, and then inside of test1, I do active folder and a new folder, call it source. Then I create another folder and I call it tests. So inside of test1 now I have 2 folders, one called test and one called source. If I now go to the evaluator and I do io.folder.move, colon, what folder do I want to move? I want to move test1/source. Where do I want to move it? I want to move it inside of test1/tests. If I now execute this, hopefully it will work. It didn't. Let's just try to move it to root.
Same.
It's probably easier with a file for me, to be honest with you. So let's delete this guy. Actually, let's keep the test one. Active folder, delete. I actually struggle sometimes for the record. I struggle with the syntax myself. But let's create a new file.
This folder and file will create on Kubernetes storage, or
yes, these folders. Let me explain that afterwards. Let me just get this correctly applied. Okay. I go back to io.file.move colon slash what was its name? foo-md foo-md dot, was it test1? Yeah. So now previously the folder was at root, now it's inside of test1. And yes, the answer to your question is that, so the job you're doing related to Kubernetes, right, you know, with the volumes and, you know, all of that stuff, this is on file. It's the file system I'm literally modifying here. These are basically files on my disk, and I can even show it to you in code if I go, let me delete this guy so I don't accidentally check in this slot. If you have the source code to Magic, you have Magic, you have not artwork, but backend, and then you have files. This is my file system. Now, by default, we are hiding some files because we don't want people to accidentally modify them. So if you click this system files, you will see that it's the exact same structure. Here you see config data, etc. MISC module system exceptions readme. Here you see config data, etc. MISC module system exceptions readme, and it's the exact same thing. Now the important part here is backend files. This is where everything is happening. So everything inside of HyperID is actually files stored inside of here. So now, of course, most users won't really, see that because they will just see these two folders and these two files. And then, of course, the physical storage of our files is, our Kubernetes, volumes that are striped and replicated and all that beautiful stuff that you are doing. So they won't really see it. But I mean, at the end of the day, it's like files. And that is the beauty of Hyperlambda, because everything is a file. Let me show you something. If I now go into my active folder, I create a new file. I call it foo.hl. And I'm now in the Cloud Labs, right? If I do now log.info x:@.arguments/*input. Okay, so what is happening here? Well, actually, I'm invoking the log.info slot, which logs an info type of argument. If I now go back to my evaluator and I do execute, and I find the io.file.execute, :/foo.hl, and then input, was it input? I can't remember. Input, yeah, input. Hello there, Mosen. And I execute this, what do you think is going to happen? If I now go to my log, what do you think it's going to display? Hello there, Mosen. You see, what is actually happening here is that I'm literally treating the file as a function, right? From my point of view here in the evaluator, the file is a function, and functions can take input arguments and they can return arguments too. Even if I wanted to, I could go back into my, let me go back into HyperID here.
Let me tell you an example. It's really, I think it's really like in Linux, everything is file. You can do anything with file. Your graphic card, driver, anything is file.
It is inspired from the pipe syntax, yes, in Linux. It is inspired from the pipe syntax in Linux. Now you saw that the file even returned the value to me, right? Return, right? Here my file is returning a value back to the caller. So there is no difference between a file, between a piece of text, between a function, a dynamically created Hyperlambda slot, or at the end of the day, a C# slot. Everything is a function object in Hyperlambda.
And I can have a slot with Hyperlambda.
You can create a slot
with Hyperlambda. And I can make the Hyperlambda file dynamically when inside of my application logic, my application business, I can make a new business and inject that to a new file, and I have a new slot, new feature that's created with my application runtime.
Yes.
All right.
Here I am actually doing that. So now I've created a new slot. If I now do signal foo node 1, this is the syntax to create a slot, slots.create. Then you pass in the name, and then you can put any amount of Hyperlambda you wish into here. I just immediately return, right? And then when I invoke it, it ends up looking like this. So it returns the value of the slot. And of course, a slot can too take arguments. I can do, for instance, math.add :x:@.arguments / actually /0 get value. Just copy this guy. 1 return :x: if I invoke this guy now, and then I do slot signal : node 1 dot int 2 dot int 2 and I invoke it, of course it returns 4. Now the weird part is I need to emphasize, if my server, Cloud Lab here, reboots, it crashes. And it reboots. I mean, obviously because of the Kubernetes network and the stuff you're doing, it will be back up running in like 0.1 second again, of course, and everything will be saved. However, my slot will be gone. So if I want to create a slot that is actually persisted in my Cloud Labs, then I need to take additional steps because the slot is just created in memory. It's never, I mean, where would it persist it? There's no file here. It's just like in memory. So if I want to create a persisted slot, I need to copy this code. Then I go into tools, I go into Hyper-ID. Then when I have a module, let's say I create a new active folder now inside of my modules folder, very important. Active folder, new folder, foo module. Then inside of this guy again, I create a new folder and this one needs a magic name. And the magic name is called magic.startup. Why? Because if you have a module and you have a folder inside of that module whose name is magic.startup, every single Hyperlambda file in that folder will automatically execute when the system starts. So if I now create this folder and then inside of this folder, I create a new file, foo.hl, needs to end with hl, and I paste my code here now, I have created a persisted slot. Now, if the system reboots for some reasons, then this slot will ensure that slot is recreated if your module is installed and or rebooted for some reasons. Right. And if you look at the modules, we are, if you go into management, you go into plugins, and then you choose any of these guys, for instance, Stripe payments. Then if you look at the code in Visual Studio afterwards, Hyper-ID, modules, Stripe, you see here is the magic startup folder. This folder has a lot of Hyperlambda files. Every single Hyperlambda file will be automatically executed as the module is installed. And if you open up slots here, you will see Stripe customers create, payment methods attached, subscription cancel, subscription create, and payment methods create, etc., etc. In addition to that, this one also creates the database automatically. So now, because I installed Stripe here now, if I go to SQL Studio, I already have Stripe database, all from blah, blah, customers, payment method, and subscriptions. Of course, there's nothing in my database because I haven't done any payments, but you know, this is where payments will be stored as we invoke the Stripe API. And then, of course, in analytics, endpoints, I can filter on Stripe, and here we have. Now I could post a payment method. I can't remember. Stripe has a card. I can't remember. And 2, 3, 4. Maybe with some luck this will work. 7, 2023, 314. Probably it won't. Probably. Yeah. Of course, I don't have a config key. I haven't configured Stripe test API key. So, but if I had, this would work in general.
Yeah. I saw before this API invoke in your examples.
Yeah. And one of the beautiful things is that when you install these plugins, you can go through the code. You can see everything it does. Everything is 100% transparent. There's no magic here. Well, I mean, obviously there's magic, but you know, there's no like, you know, hidden stuff happening here that you can't see. Here, for instance, it's extracting the username and the email, and then further down, you know, it creates an entry in the customers table associating a username in Magic Registration API with a customer return from stripe.customers create, which again, just like, you know, invokes their Stripe's payment API. Here you can see the invocation to Stripe's payment API and some sanity checking and returning the customer ID, etc. So,
if because it's enough for me, I just have to make something with Hyperlambda. I think we stop recording. I have a suggestion. Yeah.
let me just finish one thing, since we're doing this in a recorded session. Let me just do one thing, because these expressions are probably
Yes.
These expressions are probably the most complex thing. Now, if I want to add colon x colon at, this basically means find the first node upwards in the hierarchy having the name of dot dests. Right, so I want to add into dests. Get nodes colon x colon at dot data one slash asterisk means get all children of the first node upwards in the hierarchy whose name is data one. If I invoke this, then you see obviously it copied and pasted the nodes from data one and into dests. The expressions is a little bit probably the most difficult thing. If you are struggling with expressions, click getting started here. Then choose the hamburger menu up here. Then choose magic.node. And then scroll down here. You will see here are all the types Hyperlambda supports. And a little bit further down, you have Lambda expressions. And here you can see how expressions are built. They're basically built like persistent enumerators that are reacting upon each other. So it's like a piped enumerable, really. That's what's occurring, really. So anyways, I just wanted to finish that before we stop recording, because we probably want to upload this to YouTube or something. So to my YouTube listeners, thank you for listening. Have a nice day.
Thank you.
How do I stop recording?
I don't know.
How do I stop recording? This is weird.